In the last video, we began an introduction to basic low-level Java threads, and we started writing this program that would take user input, but only if they entered within a certain period of time. Now, in order to make this work, we put in two calls to cysticsit, which is kind of a very heavy-handed way of making the program terminate properly, and I like to get rid of those. Now, we'll get rid of them one at a time. The first one we're going to get rid of is this second one down here. When the main thread ends, this thread does have the ability to keep the main thread alive, but I don't want to have to exit down here. So how could I do that instead? Well, the problem we had is that without that, this would still keep counting and print times up no matter what. So we would need to have some way for this thread to know if the answer had been entered yet. And so I'm going to add a var in here called answered that starts off as false. And right after they've input their age, we'll set answered to true. Well, that means this code here only needs to happen if they haven't answered. Okay. The other thing is that we really don't want the countdown to continue. Well, the for loop is going to count all the way no matter what. So in order to make this happy, I need to change my for loop to a while loop. This is getting very imperative. It makes me feel, well, ugly. I don't, but this is what we would need to do if we're going to work with these lower level libraries for doing some of these things. Okay, so we'd print I, we'd sleep, so that this does not become an infinite loop. We need to remember to decrement I. And so now this will keep going, but it will stop if answered ever becomes true, and then this won't print and that thread will complete. So if we enter a value, it will stop without doing an exit. At least that's the theory. So if I type in 55, the program terminated and everything was happy. Now you might have noticed there was a little bit of a break in there. It actually, the termination could come up to a whole second after I enter my value, because this thread could be inside of its read and it doesn't check this. Now technically there's a little bit of a race condition going on here, because answered is being mutated in the main thread and it's being read in this thread. In this particular case, it doesn't really matter to us, because the way that this is setting it to true, if it gets, whether it gets set before or after this happens, just means that we might go for an extra second of counting. It doesn't make the program incorrect in this case. But there is a race condition here, which means that if you really wanted to worry about that, you could consider putting some synchronization on. In this case, we don't really need to, because, as I said, it doesn't cause the program to be incorrect. Okay, I still have a sys.exit in here. I still have this problem where the countdown could terminate before they've entered something. And the problem here is that readint is fundamentally a blocking call. Okay, once I call readint, there's nothing that I can do with this main thread. It's just going to sit there. So in order to fix this, I really need to make it so that the readint doesn't happen unless there is unless there's input there that's ready to be read. And in addition to that, we should make it so that this doesn't have a system.exit, but it has a way of telling this code down here when the time is up. So we're going to add another var. Okay, time up, that will also start off as false. And when we get down here to the bottom, instead of exiting, we're going to set time up to true. So if the countdown goes all the way, we'll set that to true. Then, and if that happens, then we don't actually, we would want to make sure that we don't do this, right? So we only do this if not time up. But this won't work as written because this code will print out asking, enter your age, start up the thread, and pretty much immediately fall down into here into this blocking code. There's not going to be time to check whether or not time up has been set, and so time up will not have been set once it gets to here. So we have to somehow prevent it from getting down to this if while it sits there and checks to see if the user has entered something. And the way that we can do that, I'm going to write a little while loop. And first off, this while loop should terminate if the time is ever up. Okay, that's clearly the case. The other thing that needs to happen in here is we need to check whether or not there is input for readInt to read. And it turns out there is a class in the Scala libraries called console, which has a member called in, which is, as you can see there, is a buffered reader, which has the ability to read information. And readInt is going to pull from console.in, and we can ask it if it has information ready. Okay. So while the time is not up and there is no information ready for us, we want to do this again to make it so that it doesn't just sit there and completely busy wait. I'm going to put in a little bit of a sleep. Because if I don't do this, it's just going to do this as fast as the computer can possibly go through, do those checks, do it again, do it again, do it again. I want to slow it down a little bit. There's no reason for the computer to be working that hard, especially given that humans, a hundredth of a second is something that humans don't perceive very well. So yeah, this is of sufficient quality there that humans won't notice any type of delay. And as soon as they've entered their number, then it will come down and it will hit the readInt, but readInt will complete almost immediately because we know that we have input ready. So let's try this. Now, the goal is that that still works. What about the other way? What if I don't enter anything? Then we should have it get to the end, and it should print time up and the program terminates, which is exactly what it did. Because as soon as this hits time up is true, a hundredth of a second or less later, this while loop terminates out, this if does not happen, and it gets to the end of the main thread and the program stops. So that's kind of a simple introduction to doing something with low-level Java threads. We're going to come back and we're going to look at some of the other aspects of what are in these basic Java libraries and some of the other calls that you can make to have control over threads if you want to go down to this low level. But we'll also talk about the fact how all of these things wind up being more error prone than their Scala counterparts. And that's the reason why you should be using futures and actors and parallel collections as much as you can, because they're less error prone. Okay? All of those things use these lower level things. They wind up creating Java threads, but they do it in a way where people have worked on this code to make sure that it's not going to deadlock and that it doesn't have race conditions and that everything goes smoothly and you don't get bugs.